Now, hi, my name is Lukas. I'm from Team 747, Y Boys from Wallingford, Connecticut. And this is Littleton Robotics' 2024 Crescendo robot, and I'm just gonna go explaining in depth through it. So let's get started. So first we're gonna take off the bumpers just for a better view, and we're gonna go look at the intake. So with the intake, you can see it's a full width intake, and it has wedges to center the note. Full width, and the wedges sort of play into that touch it, own it principle. This robot made it to Einstein, so clearly they did a great job at this. So the idea is if the note were to touch any side of this frame, they should own it, and it should be in the systems and working. It has a kicker roller to kick the note up into the series of rollers. This is the kicker roller right here. And then it follows this S path of rollers and brings a note to this kicker roller right here. This kicker roller right here, which then puts it to the indexer. You'll notice that there are these passive rollers right here, which further help center the note once it's already in the intake for the indexer. And that's just to help set up for the indexer. We can get a better look at the intake if we just isolate it. So yep, basically it's the intake. You'll see again those passive rollers, and then here, let's start better look. Those passive rollers, those wedges, and sort of this idea that a full frame intake and that touch it, own it. And here's a better look at that S path I was talking about. And yeah, let's go take a closer look now at the indexer. So the indexer feeds it into their shooter mechanism and their amp mechanism, or what they call their backpack, because it also functions as their trap mechanism for their hang/end game, but we can talk about that later. So this area is sort of the indexer. Let's go isolate it. So here's the indexer, and so this is the indexer. This is the kicker roll I was talking about. So basically the note after it comes from the intake approaches the indexer perpendicular from the direction it needs to be in. So this kind of flips it 90 degrees so that's ready, thus hence giving it the name the kicker roller. I think by far the most interesting part of this design is the double-sided belt, which you'll notice right here. This is a double-sided belt. This top roller and this bottom roller move in the same direction, while the middle roller moves in an opposite direction from those two. And yeah, so we'll just talk about how this mechanism works now. So you'll notice how there's sort of like this, there's a plastic pan right here. If you just do that, there's a plastic pan right here. Yeah, and so basically there's three rollers, let's say bottom, middle, and top. And the bottom and top move in the same direction while the middle moves in the opposite direction. Those three rollers alongside this kicker back here allow for a shuffling motion of the note so that the drive team can decide at any time to where the note should go, either the amp or speaker mechanism. Basically, the advantage to that is some teams from this season in 2024 Crescendo, the instant they intake their note, or even before even, they have to decide whether it goes to their amp or shooter mechanism. Well, this is like very variable and adjustable in that they can sort of store it in this limbo zone or docking bay and then decide where they want to go. So the reason why they went with the double-sided belt is they saw, hey, we're going to use three sort of rolling things, and the two are going to move the same direction, the middle one's going to move opposite. We should use a double-sided belt. It's a very compact design. Furthermore, they have these sort of what you would call tensioner idler pulleys, and these just they put more wrap around the gears, or sorry, not gears, pulleys, and this just creates for better motion transfer. Something important to note about all of these 1-inch diameter rollers right here is that they might be going through gears, pulleys, chains, belts. Actually not chains, they're just going through gears and belts, but they are all 1 inch in diameter, and they're all driven by a 1-to-1 ratio back to a Kraken X60. This is so that they all have the same surface speed, so as to prevent a note from jamming. Because if there's different surface speeds, you can imagine that one roller would be moving the note into another roller faster than that other roller is actually moving, which would cause a jam. That's just something for Crescendo to keep in mind. Next, let's go to the hang. So if we go over here, let's pop this up. Whoop. Maybe, sorry, this is the one I meant to click. Yeah, perfect. So if you look at it, this is a one-stage elevator, sort of like on the belly face of their shooter/backpack. It's a one-stage elevator driven by one Kraken X60. Interesting part about this is like the carriage. Interesting part about this hang is sort of these hooks. The top part is curved while the bottom has like this hook shape to it, and what this allows is the chain will just sort of, if it gets on the top of it, will glide over the top, but then get locked under the bottom. So as make sure that they're always grabbing that chain. It's not sort of like up here and not latching onto it. It's a nice passive mechanism, you can say, just taking advantage of the geometry. Moreover, here, if we want to take a closer look at this, just so you can see it, yeah, sort of that curve here and then that hook here. There's also some nice pocketing here. Something you'll notice about this robot is it's quite bulky, I would say, but makes this pivot. The CG is quite low when it needs to be and high when it needs to be, but with all that weight, Littleton did a very nice job pocketing a lot of their plates, as you'll see, pocket. They also did pocket on their sort of intake/drivetrain plate, but they don't pocket tube, most likely because they want the tube to be sort of very structural. But yeah, it's a good way to reduce weight on your robot. Now we can go talk about this pivot, which is honestly, I would say, the most interesting part, but also the most crucial part of this robot. The pivot allows for low CG when traversing a field, variable shooting angle, and to achieve this climb and amp position. And when I say climb, I also mean trapdoor position, which we'll talk about later. So if we go into depth on this, first we remove this cover. We'll talk about this cover in a second. So we'll find that it's a 12 to 62 ratio, then here to 16 to 60 ratio, and then it is a 12 to 65 ratio. I'm making it in total a 1 to 105 ratio on this pivot. And if we move this cover back, this cover here is smart because these gears are kind of close to the floor, close to the bumper, and it can get lots of gunk in them and get jammed, but also just to protect them because this is a full field game, so there's lots of impact, lots of hits, lots of defense, and this is just a good way to protect those gears. Moving on over to here, so this is driven quite interestingly. So you notice this has, if we remove this is a can coder, by the way, which we'll talk about in a second. So if we hide this, or absolutely coder, can coder, this is a flange sleeve bearing, which is inserted into a custom 3D print tube insert, or crush block, as some people like to say, which provides more support for the 1-inch dead shaft, which is inside the bearing. This 1-inch dead shaft is what this sprocket runs on. But yeah, this is smart. Keep in mind that these flange sleeve bearings, they're not like ball bearings. They run on sort of surface friction. But I thought the crush blocks and the flange sleeve bearing were smart solutions in order to have sort of a bigger axle to this giant 65 tooth sprocket. So we're going to just put that hood back on. You notice that the sprocket, sort of one of the sort of crossbars, you'll call it, has a 3D print. If we hide this, you'll see a 3D print right here. 3D print which attaches the crossbar to the tube of the arm. This is the tube of the arm. And this sort of transfers the rotary motion from that Kraken X60 to the whole arm. You'll notice that all this is mirrored onto the other side as well, which comes into play later. But that's smart, just so even force and even torque distributed across the pivot. And then another reason why this pivot is smart is because it's easy electronic access. So you can access the belly pan quite easily if you just lift up the pivot. So a lot of the reason why this pivot, the pivot is mostly sort of strategic, but it's also quite convenient for the electronics. Let's go into this attachment that I was sort of mentioning earlier. So this attachment, it's on the other side, but it doesn't have that can coder, you'll see, no can coder. It's based off the drivetrain, and basically what it is it holds the tensioner and it holds the can coder. So if we remove this tube, you'll see these screws right here. So this is really smart because the can coder here, which allows for the programmers here to have position on the rotation of the pivot, which is obviously very important. But using this crush block or bushing block, 3D print insert, whatever you want to call it, there's screws using this attachment from the drivetrain, which acts as a tensioner for this chain. Same thing on the other side. Tensioning chain is important because chain loosens, over the course of the season, so tensioning is required. So if you were to tighten these screws, it would pull this bearing back and thus tighten the chain. Really smart, compact way to do it. Yeah, moving on. There's these polycarb hardstops right here, and this is just smart so that the pivot doesn't sort of like fold in onto all the electronics and cameras around it, and just better protects sort of the belly pan of the, sorry Kate, just better protects the belly pan of the electronics of the robot and especially the cameras. Yeah, and let's move on to why sort of it being symmetric on both sides is kind of important. If we hide this, you'll see there's an axle under these spacers. This. this axle is connected between both Kraken X60s, and what this does is it sort of mechanically aligns that left and right rotary motion of this pivot so as to make it so the pivot itself doesn't twist itself apart. This is a great safety mechanism. Also, you don't want to just rely on software to do this, so this sort of mechanically aligns both of those. Kind of think of it like a hard stop as opposed to a soft stop, sort of same idea. Next, moving on, we're going to talk about with the little thing called fangs. It's these are the fangs. So basically, what these do is when they're going for a hang, if you can imagine, sort of the chain would be here, and the stage would be here, and the trap would be up here, so it's kind of a wall on this left side. These prevent the chain, which would be over here, from getting stuck in all the shooter and the amp mechanism and the backpack and all that stuff. It would prevent the chain from getting stuck, and also it allows the robot to hang from position when it is touching the stage. They also have a curve to help the robot react off of the stage, helping the position for the trapdoor, so this curve sort of pushes off the stage wall. This is important. The way they talked about this in their interview, it made it sound like they added this mid-season, so perhaps they were approaching their chain in a very delicate manner, which obviously is very precise, like so as to make it so the chain doesn't get stuck here, and it's approaching it from the side, from this side, but they also still have this facing the trap. It's just a very hard driving maneuver, especially if the driver can't have full vision on it, and so this is just a good solution. Make driving easier, of course, more consistency, better performance. Yeah, this reacting off the stage is huge, as we'll talk about later, with the rack and pinion mechanism that they did. Now let's talk about the shooter. So if we just lower this a bit. Boop. Okay, perfect. So here's the shooter. The left and the right are controlled independently of each other. And then also the motors are belted back near the pivot. So if we follow this belt here, we go all the way back. These are the Kraken X60s that are driving the shooter. This just makes it so this decreases the inertia of the arm created by swinging it up and down, and lowers the CG in specific for when the arm is raised. So obviously you don't want the weight at the top because this arm is raised a lot, and so don't want the inertia at the top. Just keep it sort of low, back to ground, and don't have such like a heavy arm. You'll see how it belts the top. The top belts sort of to this gear, and then this gear reverses the bottom. The benefit also with controlling the left and right individually is that they can be going at different speeds, which allows to create for spin. Spin put onto the shot gives it more stability within the air. And then, yeah, there's one Kraken X60 on each side, which is on a 2-to-1 ratio. So, yeah, this Kraken X60 to this one, 2-to-1 ratio. Yeah, and then also last thing is there's a 1.6-inch gap between these rollers. So that's just the compression that they're putting onto it. Next we'll talk about their amp mech. Yeah, so let's just get into the amp position. So we'll go left, pop it up like that, go back. Okay, so actually no, let's just fix it a bit. Pop it here, left. Sorry, my arm shape's being a little funky right now. There we go. So basically, this is a bit of an aggressive angle. It'd be more perpendicular. Let me just give one more go. Yeah, okay, perfect. So this is sort of like the positioning they have for the amp. You know, the note first goes into that indexer bay, and then you get shuffling motion. So when I say shuffling, let me clarify. It could go into the shooter, shuffle back out. The kicker kicks it back in, and then it can go into the amp. So it can go like here. It can go from like here, back, and then into the shooter, or back and then into the amp. So sort of shuffle like that. Basically, once the note's in that amp or backpack, it will is raised about 90 degrees, as you see from the pivot, and then it shoots the note, which is guided down into the amp with the rollers in a curved path. So these rollers are on a curved path so as to bend the tube so it goes down to the amp. And then now let's talk about the. I guess if you want to have a closer look, we can probably let's see amp. Backpack, perfect here. So hide other instances. So yeah, you can see sort of how it goes in that curve with these rollers, again these 1-inch diameter rollers. But the interesting part about this mechanism is how it doubles for the trapdoor mechanism. So remember that hang. Basically, what makes this one interesting is that it has a rack and pinion mechanism. So this is a rack and this is the pinion. And what this can do is it can extend that amp mechanism, and when it extends the amp mechanism up, it reaches the trapdoor for when it's hanging. So you can just imagine the robot here. The elevator clamps down. They react off of the stage, and then this goes up, and then when it goes up, it feeds it out into the trapdoor. And yeah, that's all I have for this robot. Thank you for watching.